Hello and welcome back. In my previous video I talked about the factorization of a quadratic in the form of u squared plus bu plus c, and I assume in this video that you know how to factor a quadratic in this form by finding m and n in a way that m plus n become b and mn become c. Then you can write this quadratic u squared plus bu plus c as u plus m u plus n. This u can be anything. It can be x, t, w, and so on. But now today I would like to address these equations: ax squared plus bx plus c. How can I decompose or factor this quadratic into two parentheses, two polynomial of degree 1? But as I said, I assume that you already know how to deal with quadratic with coefficient where leading coefficient is 1. Ax squared plus bx plus c, it can be written as a x squared plus bx plus c, and everything again multiplied by 1 over a, because this part is simply 1 and doesn't change anything. But the good thing here is when you multiply a into this parenthesis, you will get a perfect square for the first term, which is 1 over a squared x squared plus b times ax plus ac, right? You will get something like this. And now 1 over a, this is can be written as ax to the power of 2 plus b times ax plus ac. Now if we set ax to bu, then I can rewrite this equation by this one: u to the 2 plus bu plus ac. Now if you compare this one with this, you can see the similarity. Now actually I have a quadratic with a leading coefficient is 1, therefore I know how to deal with it, right? By using the previous video, then I can easily write 1 over a u plus m times u plus n, where m plus n must be equal to the coefficient of u, which is b, and mn must be equal to the constant term, which is ac. If I can find m and n in a way that these two conditions hold, then I can easily write my original quadratic in a factor form. Okay, now let me go through one example and see the details. Example here: I would like to factor this quadratic: 3x squared plus 4x minus 7. So the best way to multiply everything by 3 the reason that I multiply it by 3 because I would like to see a perfect square at the beginning, but because I don't want to change the equation, I have to multiply by 1 over 3 too. So this is gonna be 1 over 3 9x squared plus 4 times 3x minus 21. And then again, if you set, if you write it again by 1 over 3, this 9x squared can be written as 3x to the power of 2 plus 4 times 3x minus 21. And then here, if you set again 3x as new variable that we call it u, then you have 1/3 of u squared plus 4u minus 21. And here you need to find m and n in a way that the sum become 4 and the product become minus 21. So 1/3 of u plus m, u plus n, such that we need m plus n to be 4 and mn to be minus 21. Okay, this minus 21 and this 4. And the obvious choice for m and n can be 7 and minus 3, because the sum is 4 and the product is minus 21. Therefore I can continue this and write it as 1/3 of u plus 7 u plus n, which is minus 3. And then here it is 1/3 of u is the name of u. Now you can go back to your x, because u is 3x, therefore it is 3x plus 7, 3x minus 3. And now the only thing that left is to get rid of this fraction by multiplying this fraction into the second parenthesis. Then we have 3x plus 7 times x minus 1, and then you have the factorization of your quadratic. Let me give you another example, but in this example I will not go through everything, because if you look at my general form here, basically you can eliminate all this work, because this will be repeated all the time. As you can see here, this form repeated. So the best way is to directly use this format, the red one here. Okay, 7x squared plus 8x plus 1. I would like to factor this one. The best way is to write 1 over 7 here, and then 7x plus m, 7x plus n. Okay, and then what you need is to find m and n such that m plus n to be equal to b, which is 8 in that case, and mn is equal to ac, which is 7 times 1. 7 times 1, this one is my AC in that case, which is 7. Now the best option for m and n is 1 and 7, right? 1 and 7, because the sum is 8, the product is 7. Therefore Now you can write 7x squared plus 8x plus 1 is equal to 1 over 7 times 7x plus m times 7x plus n, which is 7. And then the final step is to multiply this 1 over 7 to one of these parentheses. Well, in this case the second parenthesis is better because it will produce this one for us. 1 over 7 times 7x will give us x, plus 1 over 7 times 7 give us 1. So this is the factored form of this quadratic. But the thing is, as I said, sum and product is not a unified way that you can factor any quadratic. In general, when you have a quadratic like ax squared plus bx plus c, if you want to factor it, if the factorization is allowed, if you want to factor it, sometimes it is really difficult to use sum and product. You can use other method to do the job, but you have to wait till next video. I will completely explain how we can decide whether it is factorizable or not, and if it is factorizable, how we can factor it. You can check, for example, this one, x squared plus 4x minus 1. It is a quadratic, but it is really not easy to use sum and product to factor this one. And another example is x squared plus 4x plus 5 is not possible to factor. This is not possible to factor. So basically we need a systematic way to see whether a quadratic is factorable or not, and if it is factorable, then how we can find its factors. So then you have to wait till next video. That's enough for today. Till next time, bye bye.